Functions. The word function is a key word in mathematics. They're very valuable, and you see them in computer science all the time. A function is a consistent rule that takes in inputs and delivers outputs. So this function takes in an input of 3 and output 7. It could take in other inputs they could also output 7. They could output other things. But the function itself is named f. The input is 3, and 7 is the output. This is the way we write it, that we put parentheses around the input. The inputs are all in blue on this page, and the outputs, f of 3 is the same thing as saying the output, when you put 3 through the function named f, it gives you 7. There are plenty of examples, and I'll show you a bunch of examples of functions. So the things that we need in a function are a name, the input and the output, which in science you usually see independent variable and dependent variable. The domain is the set of possible inputs, and the range is the set of all outputs. So what can you put in and what will you get out? And then frequently, almost always, we will have a rule. Sometimes this rule can be said in a word, sometimes it can be said in algebra, and sometimes it takes more complicated ways of describing it. So you can write that rule in English, you could write it algebraically, you could write it with an arrow diagram or with a graph. So I'll show you a bunch of ways. Here, this is an example of a function. You could call this function f. The inputs are x, the outputs are y. And anytime you see a point on the graph, well, this is 1, 6. This is saying that when you put in 1 into the function, the output is 6. This point says that when you put in -4 into the function, the output is -2. The domain here, you could put in any number, and any x value would have a corresponding y value, so it would be all real numbers. And the range here is also all real numbers. Here's a different function. If we call this g, let's call it g. What we can say is, okay, g of -4 is going to be, well, let's go over to -4. The output at -4 is -2. So here's the point -4, -2. That's saying that when we put in -4, we find out that the output is -2. Here, the output when we plug in 2 is 4. And when we plug in 0, the output is 0. Now it's worth noting, both of these are graphs. This one has a nice predictable rule, and you could write an equation from this. I believe that the equation for this one is f of x equals, 8/5 x minus 1 plus 6. That would be a rule to describe this function. However, it would take a lot more work to write out a single algebraic rule that would describe this function. They are both functions, though. This is also a function. We can call this h of x equals y, and when we plug in, each arrow represents a point. So h of 3 is 10, because when we look at 3, it's pointing toward 10. It's worth noting in this problem, h of -1 is equal to h of -2. Why is that? Well, h of negative 1 is 2, and h of negative 2 is 2, because they're both have the same output. This statement says that they are both pointing toward the same output. This would be the domain, and this would be the range. Here, this is a set of x and y values. If I call this function f, we usually reuse function names. Then I would say f of 3 is equal to 5, f of 5 equals 7. Now, you could start saying that this is the function f of x equals x plus 2. But the domain is not all real numbers. The domain is just the set of inputs. You can only put 3, 4, 5, or 6 into this function. 3, 4, 5, and 6. And the range is the set of outputs. If you look at the outputs, 5, 6, 7, and 8 are the range elements. Here, if I asked you what g of negative 7 is, what you would do is you'd find negative 7 as an x-coordinate, and it matches up with 32 as a y-coordinate, so g of negative 7 is 32. I can't tell you off the top of my head what rule causes us to go from this to this, but this is still a function because each input has a different output. But that's actually not true. This is not a function. Why? The reason why this is not a function is if we go back to the very first slide, a function is a consistent rule that takes in inputs and delivers outputs. Consistent means if I put in f of 3 again, you'll get out 7 again. And if you put in f of 3 a third time, you'll get out 7 again. Here, what this is saying down here is that g of negative 2 equals 5 and g of negative 2 equals 50. These can't have two different meanings, so that's why it's not a function. This is not a function because the input negative 2 has multiple outputs. It is worth noting that you can have two inputs have the same output. You can't have one input having two outputs. So you can put two different things in and get the same thing, but you can't start from someplace and go two different places. The input is the time of day, and the output is whether or not Five Guys is closed. So we could call f, the domain is times, and the range, so this is the domain, this is the range. The range is open or closed. And you could put in, okay, f of 10 a.m. and I don't know, they're probably closed then. I'm not sure. A carnival earns $3 for each child and $8 for each adult. Well, this is trickier. This is something that you'll rarely see in Algebra 1, but this actually would say x is the number of adults, of children. Let's call y the number of adults. And you could name a function, okay, the profit is based off of the number of children and the number of adults, which is 3 times the number of children plus 8 times the number of adults. We rarely see this where you take in two input values, but you can have functions that take in a point as an input. This is very rare that you'll see this in Algebra 1. The time that it takes to clean the cafeteria after Halloween night depends on how many students volunteer to clean. So you could say that if one student did it, it would take, 200 hours. And you could say, okay, it's 200 hours divided by the number of students who help clean. So if 20 students clean, it takes an hour. And if 40 students help clean, it only takes 30 minutes. So that's an example. The domain here would be the number of students, which would be whole numbers. You can't have part of a student or a negative student cleaning. I guess you could have 0, but then it will never get clean. So let's not include that. And then the range is going to be the pattern. Well, it could take 200 hours. It could take 100 hours. It could take 200 divided by 3 hours. It could take 200 divided by 4 hours, etc. So by looking at that, you can determine how long it would take to clean. And this is something that's relatively useful to have a function for this. This is not a function. The reason this is not a function is this input has 2 outputs. So -4 comma 3 and -4 comma -3 are both on this circle. So this is not a function. Here, this is a function because at any point there's only one output. So it is a function. The domain is from -1 to 1, so that's the domain. And then the range, it appears that that's going to about 1.5, from 0 to 1.5. Usually you'll see this written as 0 is less than or equal to y is less than or equal to 1.5. Here, this is a function. This happens to be a linear function. And the domain and range are all real numbers. That's typically the case for lines because you could plug in any x value, get out a y value. Plug in any y value, get an x value. This is not a function. You can see that this point has multiple outputs. Not a function. The general word that functions fall into, and this we would call a relation, and functions are also relations, but if you just wanted to refer to this and we're trying to use the word function, you could use the word relation instead. This is a function. We're not going to go into the range of this, but the domain is all real numbers except 0, and based off of this, between -10 and 10. This is a function. This is a function. However, it can't be described by an algebraic rule, or it probably would not be done so. It does not have to be continuous. This is a discrete function because it's disconnected. It is worth noting that most of the functions that we've looked at are continuous. This is a continuous function. This is continuous. This is continuous. Just meaning you can draw it without picking your pencil off the page, but this is discrete because there's no value between 2 and 3. There's no decimals, no fractions. This one is continuous except for at 2, where it's discontinuous. And this is continuous as well. This is not a function because all of the input values, or rather, the input value of 5, input of 5 has multiple outputs. That's why it's not a function. So let x be this domain and that be the range. Is this a function? Well, let's see if any input values repeat. So because those are our input values and they do not repeat, the answer is yes. The domain is 1, 2, 3, and 4, and the range is the set of output values, so 7, 5, 6, and 7. We don't list it twice, so even though 7 appears twice, we're only going to say it once. If we do this, well, we look at the inputs. Okay, 1, 1, ooh. So this is not a function because g of 1 is 5 and g of 1 is 8. So no,